Noble gases are different, which makes me annoyed that I use that periodic table that has them with the same color as the other nonmetals. So I got to get rid of that. Ions, as I mentioned before, have a number of protons and a number of electrons that are not equal. It's kind of hard to teach this stuff, right? Because, like, do I start with the subatomic particles and then teach you the nomenclature about the ions and isotopes? So I'm kind of doing it circularly, right? We started with subatomic particles. Now we're talking about nomenclature a little bit. Then we're going to go back to subatomic particles. Sorry. Immersion. Think of it as immersion. Yeah. So sodium will lose an electron. It's in that first column, right? And it can become sodium ion, Na+. It loses an electron. This like fringe area is supposed to be the electron cloud, I guess. Chlorine can pick up an electron. It becomes chloride ion. It's in that halogen immediately to the left of the noble gases column. Metals lose electrons. Nonmetals gain electrons. A positively charged ion is called a cation. A negatively charged anion, negatively charged ion is called an anion. Just nomenclature, vocabulary. Okay, so this is a better periodic table. They have different colors for different columns. And as you can see, what happens to fluorine, chlorine, bromine, iodine is that they pick up one electron to gain this noble gas configuration. So they end up getting, as ions, -1 charges. Oxygen in that group needs 2 electrons to get to the noble gas configuration. So they get to steal 2 electrons to get -2 charges. And actually, even with nitrogen, sometimes we'll talk about nitrides. Those are nitrogen -3 ions. On the other side, these metals are in the first column, the first group. They lose 1 electron. These metals are in the second column, the second group. They lose 2 electrons. The position of the column tells you what's going to happen with the element. And that's very useful stuff. I mean, I will be able to give you, on an exam, the periodic table and write down, you know, lithium, what ion will it most commonly form? And you should say, wow, well, on the periodic table, here's lithium. It's in the first column. So I know it's going to lose an electron generally, and it's going to achieve the helium electronic configuration. Which atom is most likely to form a 1- ion? I love this. And of course, okay, so let me see if I can copy that and then put it there. All right, there's that. And all right, so let's go ahead and vote on this one. Oh, I'm going to kill it. Hang on. Let's do a new one. So there's no residuals. Go ahead. Which answer? A, B, C, D, or E? I'll give you a hint. If it's not if it's not populated in the table, it's not going to be the answer. So don't put down D. And don't put down C. Okay, so which of these is most likely to form a -1 ion? We have 3 for A and 3 for B. -1, that means it's going to be 1 away from a noble gas on the far right. So that means it's going to be in this column, the 7 column. It's going to be like fluorine, chlorine, bromine, or iodide. A is a good answer. We have some stragglers with B. B would form a negatively charged ion, but it would be a -2 ion. The sulfide ion is going to try to pick up 2 electrons to gain the noble gas configuration that's closest to it. Okay, which atom is most likely to form a +2 ion? Sorry about that. I'm going to steal the periodic table again. And Okay, so which one is most likely to form a +2 ion? +2 means it's going to be losing 2 electrons, right? So from the neutral atom, it would lose 2 electrons to gain a noble gas configuration. So it's going to be one that has 2 more electrons than the nearest noble gas. So what do we got? Oh, we got to start it. Sorry. You guys are like very patient. You gotta yell at me. All right, we got some people going with E. Does anybody want to say not E? Does anyone want to say nitrogen after I said nitrogen is going to have a 3-. All right, everybody loves E. Very good. So E is calcium. See, it's over here in the 2 group. It's a metal. It's going to lose electrons. It's going to lose how many? 2 to get to this noble gas configuration. Pretty straightforward. I mean, we haven't covered how the orbitals work and why you'd want to lose electrons like that, but you can play the game, right? You can play the board game at this point. So I can give you a periodic table and say, here you go. You'll be like, oh man, that's really close to the noble gases. It's slightly on the left. It's like in the 6 or 7 group. I know it's going to pick up 2 or 1 electrons. And if it's in the 1 group, it's got just 1 extra electron. It's going to lose 1 to gain a noble gas configuration. So we're doing this. Another word for noble gas configuration might be I might say like a complete valence set or a complete outer shell of electrons, something like that. Whatever. You'll know what I mean when we cover it. Now we're going to cover ionic compounds. So salts are another way of saying ionic compound. So when someone says a salt, they mean an ionic compound. When you write the formula for an ionic compound, you need to make sure that the charges are balanced. So if you think about a sodium ion, it has +1. See what I say? Chloride has -1. So 1 sodium and 1 chloride gives you a total charge of 0. So to balance the charges in lithium nitride, you would have to have 3 lithiums to balance the -3 charge on the nitride. Each lithium is a +1 cation, right? So that's 3 times 1 gives you a 3+ charge, and a -3 gives you 0 total, right? 1 + 1 + 1 is 3, -3 is 0. That's how we write salts, or ionic compounds. What is the charge on the barium ion in barium chloride? There are actually 2 ways I can show you how to do this. See if I can give you a periodic table again. Okay, what do you guys think? E, +2. Okay, so there are 2 ways to do this. The first way is to just look and see what column barium is in. It's in this 2 column. Those always give up 2 electrons. There's really no ambiguity there. So just by looking at that, you could say barium's going to be +2 to gain this noble gas configuration. What you could also do is say, well, chloride, I remember that's -1 because it's over here. And there's 2 of them, so that means whatever the charge of barium is, it has to be able to balance 2 -1 charges to make the whole thing neutral. So it has to be +2, right? Because +2 -1 -1 is 0. Does that make sense? It's like balancing a checkbook. It's really accounting. You came here for science class and you're not getting one. You're getting an accounting class. Okay, lead sulfide. So one thing about the periodic table is that like some of these elements pretty constantly give you the same charge. Some of them don't. Lead is one of them that's ambiguous. It could be +2, it could be +4. Who knows? So we're going to have to use the second method of balancing. So what I want you to do, what I'd like you to do is figure out what's the charge on sulfide, on that disulfide? So each sulfur is what? Is it -2? Just does not like me. Wow. There's some serious goalie action. So sulfur is in this column, right? So a sulfur is going to have a -2 charge. How many are in lead sulfide? 2. So there are 2 sulfurs here. That means that there's 2 times -2, -4 charge on these 2 sulfurs. What number with -4 equals 0? Yeah, +4. Okay, so we know that lead has to be lead 4, or lead +4. Okay, so let's see. Does anybody have any questions on any of the material we covered right now? Yes? Yeah, we can break this into pieces. It's not